In this video, we're going to look at coming up with an exponential equation to model a situation where we know a couple data points. Now, you may have done something called regression where you have a whole table of points and you use technology or Desmos or something like that in order to calculate a line of best fit or an equation of best fit, where maybe the data doesn't fit the equation exactly, but in this scenario this is a little different. We only have two pieces of data and we are going to find an exponential equation that will fit both of these pieces of data perfectly. So it's a little different than a regression. So first of all, we need to review what an exponential equation looks like so we know what we're trying to build. So an exponential equation is going to be in the form y equals a times b to the x. And let's go ahead and make this a and b some different colors here to remind ourselves what these mean. So a, this is your initial value. All right, if the value of x is 0, let's just write this out. If I put 0 in for x, b to the 0 power is 1. No matter what b is going to be some number, but b to the 0 power, no matter what b is, that's going to be 1. So y equals a. So what this is telling us is when x equals 0, y equals a. So that's basically your y-intercept. That a value is your y-intercept. Okay, let's just write that down. A value is my y-intercept. Intercept, I should say. A value gives me my y-intercept. In other words, the point 0a is on your graph. All right, what does the value b tell us? B is your growth factor or your decay factor, the base of your exponential function. That's why it's a b. It's your base. All right, so if you have a percent increase or decrease, you could say that b is equal to 1 plus the percent if you have a percent increase, and b is equal to 1 minus the percent if you have a percent decrease. So we're going to have to figure out what the value of a is and what the value of b is. Another way you could think of it is your multiplier. Your base, b is your multiplier. What are you multiplying by each time to get your next value in your chart? Remember, linear growth involves adding or subtracting a constant. Exponential growth is going to be multiplying by some number over and over and over again, and that number is b. So in that way, it's analogous to the slope of a linear equation. All right, so let's look at the information that we have here. Let's just keep this in our minds because that's what we're trying to build. The value of a brand new 2010 Ford F-150 truck in 2010 was $31,500. In 2018, that same truck is worth $14,200. A, assuming an exponential model, find an equation that models the value of the truck after t years. So for part A, our input is x and our output is y. Now in this case, our input is t. And we could call, I guess, we could stick with y, or we could do something else. We could stick with y. It doesn't really matter. Input t is time and y is the value of the truck. I guess if we wanted to make it a little more analogous to the situation, we could call this output value v. V for the value of the truck, or p for the, I don't know, price, whatever you want. So t is the input. We'll go with v as the output. And let's take the information in part A and put it into a table. Now, one thing you always want to remember to do when you've got years, you don't want to put 2010 here in for t. You need to have some starting year. This truck didn't exist before 2010. All right, so we're going to say that t equals 0 corresponds to the year 2010. So when t was 0, the value of the truck was $31,500. And when, let's see, 2018, so what would be 2018? 2018, t would equal, hopefully you can see that would be 8, right? 8 years later. So t is 8, that's 8 years after 2010. The value of the truck is 14,200. This is a spot where students get a little messed up, is figuring out what this value of t equals 0 is going to correspond to. So always keep that in mind and have that as part of your equation. We'll write that when we have our final equation. All right, so let's think about what we need to find. We need to find a, which is our y-intercept, the point 0a, and we need to find b. Well, we're in luck because the point 0a is right here. Now, if we didn't have that, solving this would be a little bit different, but a lot of times you are given the initial value or the starting value of the whatever it is that you're modeling, all right? It could be a population or number of bacteria or something like that. So we know our A is 31,500. So now we could rewrite our equation, which is going to be V equals 31,500 times b to the t, and we still don't know what b is. So what we're going to have to do is we're going to have to use this information right here and plug 8 in for t. 8's going to go in for t, and 14,200 is going to be the go in for v because that's the corresponding value. Then we'll be left with the variable b, and we're going to solve for that in order to determine the value of b. All right, so when we plug these in, we get 14,200 equals 31,500 times b to the 8th power. Now we can solve this for b, and we will have the value of our base. All right, so to solve this, first thing we're going to do is divide by 31,500. Now this is another spot that we need to talk about. Should I punch this into my calculator and get a decimal? Whatever that decimal is, I'm sure it's not super nice. So I would not plug this in just yet. I would just leave this yucky fraction. I mean, I guess since it's easy to reduce this factor of 100, I would do that. So now I've got, let's go up here. We've got 142 over 315, and that very well might reduce, but I don't care. I'm going to end up punching this into my calculator. You could leave the zeros there if you like. Now, how do I solve this b to the 8th? Well, what undoes to the 8th power? That would be the 8th root. So there's a couple different ways you could think about this. You could do the 8th root, so you need to know how to do this on your calculator. If you don't, drop me an email. Or another way that you could punch it in is take it to the 1/8 power. So remember, the 8th root means the 1/8 power. So you could also think of this or punch it into your calculator like to the 1/8. So one of these two things right here, you need to punch in your calculator. So you should pause the video and do that with your calculator so you can make sure you're getting the same answer, because there's some places you can run into trouble here. My calculator says 0.905205582. I'm going to run out of space here. And then it has a 29. I'll just stop right there. Okay? That's good enough. I mean, this number is probably irrational, and very likely irrational, and goes on forever, so you have to round it at some point. This will be fine. Probably the directions of whatever problem you're doing will tell you. I would probably, since this is representing a percent, I would probably even round it like that. So basically this is saying about 90.5%. It's retaining about 90.5% of its value every year. In other words, it's losing 9.5% of its value every year. The truck is. All right, so now we have our equation, which is y equals, we plug in our value of a, our initial value of 31,500, and the truck is going to lose 9.5% or retain 90.5% of its value every year. Oh, I used y. I said I was going to use v. Let's go back and be consistent, and we'll call that v. All right, so there's our model. That is the answer to part A. Now, just to check this, kind of be a good idea to check this, we could plug in 8 for 2018 into our equation. So V equals 31. Now, remember we rounded a little bit, so this isn't going to be perfect. But if you punch that into your calculator, let's see what it comes out to be. Think about what you would expect it to come out to be. I mean, we're hoping it's going to come out to be this. Let's see. When I punch this in, I got $14,174.22. Now, that's interesting because that's, you know, what, $26, $25 off? That's kind of significant. And why did that happen? Well, it happened because I rounded this base value here. So if we wanted to get a more accurate answer, a more accurate model, we just do more digits for our base. Okay, let's go look at part B. All right, so I've transferred our equation, our model equation here, to the next page. And I've added a couple more digits here to my base just to get a little more accurate answer. All right, so part B says, based on the exponential model, what's the predicted value of the truck in 2022? So remember, t equals 0 corresponds to the year 2010. So 2022 would be how many years after 2010? What would that be, 12? So 12 years after 2010 is going to correspond to the year 2022. So if we want to know the value in 2022, we need to plug 12 in for t. That's it. That's all we need to do. So the value of the truck is $31,500 times our base to the 12th power. Now, if you think about what this means, if you take the 31,500 and you multiply it by approximately 90% here, that's going to be the value in 2011. Then if you multiply it by 90% again, it's going to be the value in 2012. And if you multiply by 90% again, it's going to be the value in 2013. So you're multiplying by 90% approximately every single year. So to get to 2020, you're going to have to do that 12 times. It's that repeated multiplication that is really at the heart of the exponential model. So go ahead and punch this into your calculator to make sure you're doing your calculator right and you can get the right answer. I got $9,534, and since this is money, I'm going to round to the nearest penny, 60 cents. Now again, if you're using more or less decimals for the base, you could get a slightly different answer. All right, part C says, in what year will the value of the car drop below $10,000? So here we're given the value of the car. Plug that in for V, and we're being asked to find the value of t. Now, there's a couple different ways to do this. One way is graphically, and another way is using logarithms. So I'm going to first show you, or I guess 3 ways. You could do guess and check too. We can see right here after 12 years it dropped below 10,000, so maybe we'd try 11 years. Or look at a table of values on your TI-80 whatever graphing calculator. You know, you could punch this in and then look at a table and see when did it drop below 10,000. That would be a great way to do it. We could also look at the graph. I have a graph here for us to look at. So decimals is a great way to graph if you're using online stuff. You could also do this on your graphing calculator. So in decimals, I'm going to add a table, and my first x value of 0 was 31,500. And then, what was it, 8 years later, it was 14,200, right? Okay, now notice over here I've had to set up my scale so this makes sense. And in decimals, you do that here with this little wrench, and you can set these how you want. In your graphing calculator, you have to go to the window and change the Y min and Y max and all that kind of stuff. A lot of times students, say, oh, I can't see the graph. Well, that's because it's up here at 30,000 and you're only looking at a 10 by 10 window. So that's important to make sure you have your window set. Now, let's put our equation in. We had y equals 31,500 times 0.90, what was it, 90521, 90, okay, 905, to the, and we use t, but we'll use x here. Okay, so look at that. See, here's our points, 0, 31,500, and this is our, oops, I'm not hitting it just right. This is right here, our 8, where that blue dot is right there. That's going right through our point. This is a great model, looks good. Now, if I want to graphically look at when will the price be 10,000, I'll put y equals 10,000, and this dot right here tells me exactly after how much time it'll be 10,000. So at 11, it would be up here. This would be the point where it's at 11. If I can get that. 10.84. 10, okay, that's pretty close to. Oh, I had it. Oh, stay there. Okay. So at 11 years, it's at 10,533. And we already know at 12 years it was less than that. So right here at 11.5, it's 10,000. So it's going to take 12 years. Since it's asking for how many years, you'd round up to the next year. You know, so that's kind of cool. You could just put any number you want. You want to know when it's going to be less than 5,000? Just put in 5,000. Here's this point. So after 19 years, it's going to drop below 5,000 in its 19th year, the value of the car. And this piece of the function is really worthless for our model. It's from 31,500 forward. All right, so graphically, we can see that it's going to be after 12 years. Now, logarithmically, I'll go ahead and show you how to do this with logs real quick if you want to know how to do that algebraically. So the first thing you want to do, and if you haven't studied logs yet, don't just, stop the video. You got what you got out of it, and you'll learn logs later, and you can come back, or maybe you want a preview of what this log thing looks like. All right, so first thing we're going to do is we're going to divide both sides by 31,500. And again, I'm not going to punch this into my calculator because I don't want the messy decimal. I might cross off the zeros to make my life a little easier. And actually, if you want, you could reduce 100 over 315 because they both have a factor of 5. But I'm just going to leave it like this for now. So now the question is whether you have the capability of doing different bases on your calculator or not. If you can do different bases on your calculator, you simply write this in log form. So you write log base, and the base is the same base as it is for your exponential equation. Log base 0.90521 of 100 over 315 equals the exponent. The answer to a log is always the exponent. And then you would just punch this into your calculator. And I think on the TI-80 stuff, under math, maybe, there's a button that says log base. Yeah, if you hit math on your TI-83, 84, and scroll down to option A, there's an option that says log base. So you just click that and you put in the values. So when I put that into my calculator, I get 11.521. All right, that should correspond to what we got over here on our graph when we were doing 10,000. Right here, 11.521. There it is. Perfect. Okay. So if you don't have the capability to do different bases on your calculator, then what you would do from this point, go in this direction, is you would take the log of both sides, or natural log or common log, because you have those buttons on your calculator. I'll just do common log, log. And when you have a log of something to a power, you can bring the exponent down in front. All right, so that's going to give you, most of the calculators have the ability to do different bases now, so this little strategy is not as helpful as it has been in the past. So I'll bring the t down in front, and the reason I have to write this as a common log is because I have that button on my calculator. So now I can divide both sides by the log. Common log, log base 10 is common log, and you have a button on your calculator that says log. Everybody has that button, and that's what this is referring to, this common log. So now you can punch into your calculator. These cross out. log of 100 over 315, all divided by log of 0.9052, and you should get the same exact answer of 11.521. And you should try that on your calculator. Practice with your calculator and make sure that it's working. All right, I hope this was helpful. And remember, when you're starting this process, back to our first slide, think about what an exponential equation should look like, and importantly, what these two values represent. My y-intercept is my a value, and b is my base, or what I'm multiplying by each time in order to get the next value in my table.